Welcome to class number 106. See, nowadays I am taking live classes, that is starting from class number 101 onwards. All these days I have been taking live classes. Reason all I will tell later. Usual continuation will come later. Some furthermore details will come little later. Now, today I already sent the link or created a class for 106 for live, but some technical problem was there, due to which YouTube was not responding. So I finally cancelled it. And I put the title, Very Important Practical Concepts for today's class. Now, that I will take live in the next class only. So what I decided is, last time for this question, everything was over. I located points of contraflexure. I just gave the equation how to locate and stopped. I asked you to get the answer. So today's class I will make it exclusively for location of points of contraflexure to make completely clear, once for all settlement. See, this all, everything already over last time. Don't see this x1, x2 time being. See, SFD was drawn, BMD was drawn, everything was explained for the continuation. Now see, once everything is over, see, after finding bending moment at C, A, E, F, B, D, and also G. G is the point where SFD crosses the baseline, or where shear force is 0. That is where BM is maximum. See, as I told, draw a tangent here, 0 slope. This all told last time. So now, today's topic special. SFD, BMD, class 106. Location of points of contraflexures. Flexures, why? There are 2 points. See, I wrote class. Something I am dictating now. Those who are serious should write everything. So for you, first you should go through class 105 and prepare the bending moment diagram. Okay. Now, or if anybody wants to learn only how to locate points of contraflexure, these all you have to assume. You have to believe me. Okay. Start. BMD, see, right here, class, BMD is drawn. BMD is drawn. Observe the bending moment diagram. Observe. Yes, I am observing here. Check whether bending moment diagram crosses the baseline. Simple, I am telling simple language. I can go to high level, but no, so that you should understand. Crosses the baseline, or whether bending moment diagram, from you get points where from negative it will change over to positive, or from positive will change over to negative. Answer, yes. See, 1 point here, 1 point here. One is after A, before E, other is after F, but before B, if you go from this side. Answer is yes. Right. Those points are called points of contraflexure. That is where BMD will change the sign. That is, from sagging it will change over to hogging, or from hogging it will change over to sagging, depending on from which side you are coming. Okay. Now, write everything. We have to locate those points. How many points are there? 2 points are there. One between A and E, other between B and F. So, in the bending moment diagram, mark it. See, this all see later now. I will continue now here. See, location of points of contraflexure, heading over. These all I will explain later for you. First step, right there. Before that, remember, you are right. Yes, there is a point of contraflexure between A and E. See, A and E. And also from this side, if you start, between B and F. That much statement you are right. Now, first, location of, I will put shortcut now, point of contraflexure, simple language, POC, between, which points? A and E, between A and E, between A and E. Okay. Let means what? That point, let it be x1, some name x1. Why x1? Unknown point. One more point comes, I will call x2. Okay, x1, comma, where is x1? Come back here. It is here, see, point, let it be, 1 minute, let it be 1 minute here, you can write, let it be O1 Instead of x1, I'll call O1. Better. See, no x1. O1 because O means 0 point. Okay, O1. Change the language. O1, comma, at distance. See, point O1. From nearest point from here, I will take distance x1 corresponding to O1 x1. At x1 from, see, I am seeing from that side, from A. A is a standard point, x1 from A. Therefore, remember, see, the point comes after A, but before E. So, it has to be more than 0. The value of x1 should be, from here if you start, you have to go inside. The x1 value is more than 0 and it should be less than 5 meter. Common sense. Therefore, see, your x1 value should be more than 0 but less than 5 meter is the condition. This is the condition. Comma will be condition. Okay, this is very important. Okay, now start. How to locate? See, in case there is no UDL here, then it will be a straight line. Then you can do one thing. You don't have to struggle. If you want, you can locate that point by using similar triangles. Why? See, 440 divided by x1 equal to 1287.5 divided by 5 minus x1. Only if there is no UDL here, there is no load is there. See, it will be a straight line. But here you can't do that way because it is parabolic variation. For parabolic variation, you cannot apply similar triangles. It is nonsense. Therefore, now see, how to locate x1? See, to locate the point x1, not x1, O1. Okay, to locate the point O1, sometime it happens, O1, that is to get the value of what? To get the value of x1, to locating the point O1 means getting the value of x1. What you have to do is equate bending moment at the point O1. See, at this point here BMD crosses the baseline. You know BM is 0 here. At O1 to what? To 0. To 0. Start. Therefore, don't see that side now. Bending moment at O1 at this I put x1 here. I am changing to O1. Okay. Sometimes such small things happen. Okay, I always prefer O1, O2 for contraflexure. No x1, x2. I prefer O means 0. Okay, bending moment at O1 equal to, write the bending moment here. See, what to do? Actually, you make a note. See, once you decide this is x1, go back, write statement here, go back. From, see, the point is somewhere here, at x1 from here. Light line mark using pencil. Don't disturb the figure here. You see, once you enter here, this is x1. So, somewhere here, we want bending moment. So, see here, bending moment here equal to minus 60 into 4 plus x1. See, I'll write here now. It is minus 60 into 4 plus x1. x1 is red color. x1 again minus 25 kilonewton per meter for 4 meter plus x1. So, minus 25 kilonewton per meter into 4 plus x1 is the total load. These all can't be explained now. Multiplied by its center is at 4 plus x1 divided by 2. Okay. Lastly, plus 568 into directly x1. Equate the bending moment to 0. Now, this is without any construction referring here, or do one thing, make a note. Just to first time you are studying, see, make a note. I have put one more diagram here. See now, the same diagram, C up to E I wrote here. Further I am not interested. From C up to E, because why? Your point comes here. I even draw the bending moment diagram also here. See, it will continue that side. Don't worry. Continuation, don't worry now. See, it will continue this way. Not required for us. See, this is x1. If this is x1, this is 4. This will be 4 plus x1. So, If you have confusion here, you can refer here first time. After practice, refer there only. See, here bending moment equal to, see now, this is 4 plus x1, see, that point O1 is somewhere here, see now, minus 60 into this distance, 4 plus x1, minus 25 into this length into that length by 2, 25 into 4 plus x1 into 4 plus x1 by 2, plus 568 into x1, equal to 0. Now you have to make a note. This is quadratic equation. Why? x1 into x1, x1 square. In my class here, I won't waste time on simplifying this one. I may require a lot of space. That you can do. Those who are serious, you should know how to simplify. Or nowadays, in calculator, you can feed this equation and solve, it will give. That is your mathematical capacity. So note, solve the quadratic equation. Now, very, very important note you are right. When you solve a quadratic equation, you see x1 square will come here. You will get two values. One of them, sometimes, one of them will be positive, one of them will be negative. Here see, your x1 cannot be negative because you took distance from here to this side. It can't be negative. One of them will be positive, one of them will be negative. Then that positive is the answer. But it happens so many times that both value will come positive. You never bother. You solve and get both the values. I already solved it so that I don't have to waste time here. So note, solving, you get x1 equal to, I noted down here, 1.1163 plus 163 meter, and second value is plus 31.5234 meter. I'll write here, space is not there, comma, plus 31.5234 meter. These are both are positive. Now, if both are positive, what to do? If both are positive, see, there is only between after A up to E, there is only one point here where bending moment is 0. So when both are positive, you consider the applicable value. So make a note here. See, x1 equal to how much? 31.5234 meter is not applicable. Is not applicable because reason, your x1 should be less than 5 meter. I written here, your x1 should be less than 5 meter. Therefore, applicable value of x1 is 1.1163 meter. Okay, done. Then one note, go back, not go back home, go back and enter. Enter, come back here. In the diagram, right here, neatly. x1 equal to, how much I got? 1.1163 meter. Calculated value, enter. Okay. Now, one important concept. Usually I ask it in the class. One of them is FC. Our decision is what? x1 is more than 0 but less than 5 meter. So you got how much? 1.1163 meter. Other you got 31.52. From after A up to E, 31 is not possible. So not applicable. I will usually ask the question in the class. If it is an offline class, students, suppose you get both applicable values, what you will do? Like, I will tell, don't see here, one value I get randomly, I will tell, one of the value I get, don't see here, 1.2 meter, other you get 3.6 meter. See, yes, from here to here is 5 meter. 1.2 is, don't see the diagram here, 1.2 is okay, after A, before E. 3.6 also okay. What to do? Usually student will tell, sir, take the lesser value. I will ask them, why lesser value? Sir, because if you see the diagram, sir, you can make out it looks like lesser. Then I will tell them, see, so many times what happens is your negative BM will come very small here and positive will come, negative will come very huge here, positive will come lesser here, diagram can come this way also. Then if it is 5 meter, it will go beyond 3 meter, possible. So don't tell by looking at the diagram, it is mathematics. Then they will tell, sir, lesser value I have to take. But why? Sir, told that way in the college all. Oh, see, they will tell that way. No. Then I will ask them, do you know what I will do? Ask me what I will do if I get both values within the range. Means x1 is more than 0, less than 5 meter. Suppose you get both applicable value. Means what? Both of them comes more than 0, less than 5. Like I told 1.1, 3.6. They will not ask the question. Ask me. Then one of them will ask, sir, what you will do? I will tell the answer. What I will do? I will tell, let it come if possible. If the beam has got courage, let it come. It will not come. I will tell them, announce. If it comes that way, right at that time, I will stop my teaching. It will never come. It never came so far. It will not come now. It will not come in future. I am responsible when only one existing point is there in a region. Two applicable values can never come. Take it from me, my guarantee. Then they will tell, okay, sir. If you tell that way, yes. Next time I will ask some other way. If you get both applicable, what to do? Sir, will not come. How you know it? Sir, because they will tell same thing. Sir, you told. Okay. So this is how to locate. Now, we located the point O1. That is, I am telling all this way to give you confidence. It can never come. I am responsible for it. If it comes, mathematics is wrong. That's all I can tell. If you get two applicable values, when only one value is existing there, it is called mathematical mistake. So complete mathematics is gone. If mathematics is gone, what to do? All subject will flop. Okay, nothing to worry, it will not come. See, now we got this point. Now I will do one thing now. Start. I will remove location of now. Rest. Point of contraflexure between, I will do from this side. B and F. I will change it here to save the time. Okay. Between, I will finish everything now. B and F. Let it be point O2 at x2 from B. Okay. Now, therefore, your x2 should be more than 0 and less than 6 meter. Why? After B up to here, it is 6 meter. So it is somewhere, actually it is very near to 1 meter. See, you can make out very near. That all you don't see. Mathematics will take care. Okay, now we start. Light line, right. Let it be O2 at x2 from B all over. To locate O2. To locate O2 means to get the value of x2. Equate BM at O2 to 0. BM at O2 to 0, or those, actually these diagrams are not required. In the beginning I wrote because first time I am doing in the class. After some time, confidence count. See, come here. There is a point here O2 at x2 from here. Light line mark here. Put the finger here. Write BM here. Look this side. 100 into 2. Don't see 6 meter now. Now 6 meter is gone. 100 into 2 plus x2 negative minus 25 into 2 plus x2 is the total UDL into total load due to UDL into 2 plus x2 by 2 plus 512 into x2 equal to 0. Or I write here BM at O2 equal to, okay, this I will remove. Why unnecessary? I remove everything because I fresh I will write. See, now in spite of that one, if by chance something I forgot to erase means, okay, A, B, C, D, okay, between B and F, people are waiting to find a mistake. Okay. O2 equal to, or do one thing. One more diagram I write here. See now. I wrote from D up to F and that much diagram. See now. If this is x2, this will be 2 plus x2. Your BM required is where? Here. So here BM is how much? See, look this side. 100 into this distance minus 100 into means you know what is that into? 2 plus x2, then minus 25 into this loaded length. 25 into how much it is? 2 plus x2 is the total load into its center is 2 plus x2 divided by 2, lastly plus 512 into x2 equal to 0. Now same as last time, write the note here. This is a quadratic equation. Solve it. You will get x2 equal to, I already solved, plus 0.7079 meter, and other value is plus 28 point. This I calculated because easy for me. Actually, if you want only value, I can directly do in calculator. Tricks are there. Later I will tell you. There is a trick even to locate the contraflexure point. If it comes in UDL, you don't have to solve quadratic. I will tell the trick later. Direct trick. Within no time, you get the answer. See, for if you want information, I will really apply the trick now. I will tell something. Shear force how much there? 362. It is 362 square minus 2 into 25 intensity into bending moment here is 250 equal to root of that answer. I will subtract the shear force there. How much it is? 362. I will divide by intensity of load 25. Oh, something went wrong. Okay. Once again, no problem. Where is the bending moment there? Oh, shear force there, 362. Once again, I will do it. Calculator was not fully on. 362 square minus 2 into 25 into the bending moment there is 250 equal to root answer. Then I will subtract the shear force there, 362. I will divide by intensity of load, 0.7079 meter. Yes, I got applicable. These all tricks I will tell later. I did second time because first time calculator button, when I pressed the button, wrong button I pressed. Okay. Now, make a note here. Same as last time. See, x2 equal to, how much you got? 28.2521 meter is not applicable. Is not applicable because your x2 has to be less than 6 meter. Therefore, I will write here applicable value of x2 equal to 0.7079 meter over. Right, note, go back and enter in the bending moment diagram. Enter here. x2 equal to 0.7079 meter over. This will finish location of point of contraflexure for our beam. I told systematically. Now onwards, when I continue the question, if contraflexure point comes, I will put the equation, I will give the direct answer. I will tell you solve, or I will tell that special class number 106, thoroughly explain. Those who are serious, it is sufficient for them. Not serious, you know my usual answer. Now, next class, 107, I will again continue live, and I forgot to tell, I will give the practical importance or very, very important concept of overhanging beam. So many explanations will be there. Practically very important, even theoretically also important. If somebody is writing the competitive examinations, all what I am telling next time will be very, very useful. Next time is not one class, maybe 1 or 2 class, 107, 108. It will be very, very useful. So many principles will be learning, that hogging, sagging both are there. And I will explain one more thing. See, now I will tell later one small important. Now you can tell one thing now. If you see the bending nature now, see, this I will tell you tomorrow, next class. See, I will project the point here. From C up to O1, beam will only hog. Why hog? I am not putting elastic curve. I am showing only bending nature. Elastic curve is something else. And even this point to this point also, beam will only hog. Whereas between O1 and O2, see, this is a point O1, this is a point O2. Between those 2 points, beam will sag. Elastic curve, I will explain later because not this way. This is just explanation. And so many people make a mistake. They will tell, I will tell tomorrow, overhangs will hog, between support, beam will sag. No, the hogging will continue for some more length. And sometime it will continue for an entire inside B part also. These all practical knowledge I will give you tomorrow. Okay, thank you. Go through this class. This is alternative to the live class in the series. Tomorrow once again I will come live. Okay, thank you.